In this lesson, we will use the hping3 utility to assess organizational security. We are in the hping3 portion of the video series. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the operations and incident response section of the exam. So what is hping3? The hping3 command is a network tool in Linux used for crafting and sending custom packets to target hosts for various network-related tasks. It was developed by Salvatore Sanfilippo and maintained as an open source project. It was first released in 1998 and has been actively developed since then. We will use it in Kali Linux. The hping3 command is used in the Linux terminal or shell environment. It is used for network testing, firewall testing, advanced port scanning, trace route generation, and security auditing. It achieves its functionality by allowing users to construct and send packets with various protocols and options using custom headers and data. The rest of the how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the show notes below. Also, if you like this content, make sure to subscribe to the channel so you won't miss any new videos. And we're back. So we have our companion guide, we have Kali Linux on top, we have a new member to our pen test environment. So we have this Windows 10 machine here in the lower right, and let's go to our network diagram so we can see what's going on here. So we have Kali Linux, that is our offensive security device. It's sitting here at 172.16.1.103. Let's go ahead and verify that. So I head over to the terminal emulator. There's a variety of ways to get there. As you know, you can do Control-Alt-T, you can right click on the desktop. I'm just going to click right into it here and give it a moment to fire up. If I want to make this screen a little bit bigger, I do Control+. I'll just do that 2 times so you can see that, maybe just a slightly bigger one here. And to verify the IP address, I'm just going to do an IP adder, and we see that we have 172.16.1.103 that coincides with our diagram. And we also see that we have the Ethernet address over here as well, and we have the 08002753 Charlie Bravo Alpha, and we see that here in our configuration as well. So we're looking pretty good here. Let's just do this from an if config perspective as well. So I can do if interface configurator, and this gives us the same information here. So this is the IP address, and this also gives us the net mask or the MAC address right over here. So we're all set there. So what I did in this case here, this is going to be our offensive security device, Kali Linux. This is for red teaming, which is why it's shown in red. And this is our new target machine, which is a Windows computer. And this will be our target. And keep in mind, we needed to do this because these are considered dangerous tools or invasive or intrusive tools. And we want to make sure we have our own environment to do this. So on the Windows side, I'm just going to do the same thing here. I'm going to go to a command prompt, CMD, and don't worry, we will have a full lesson on the installation of the Windows 10 VM. This is to give you a sense of what it looks like from a target perspective. And I'm going to do IP config just to see this here. IP config is the IP configurator, and I want to make sure this matches. I have 172.16.1.120. That's the IP address here. It shows me the mask of a /16. This coincides with what we have here, so that way we make sure we're on the same network. And if I want to see the whole thing, I can do ipconfig/all. And when I say everything, meaning a little bit more about the IP configuration. For example, I wanted to see the MAC address, and it's coming in at 08002766 Alpha Delta Foxtrot. So same thing here. Just a quick thing to make sure we can ping each other. So I'm going to ping the Kali box. So it's 172.16.1.103. And in typical fashion, Windows is going to send 4 packets. So we know we have connectivity from the Windows to the Kali box. We're going to see the Kali setup in a little bit, because we're going to actually use hping. So I go back to the lab. I see that I have my terminal screen. I have my Windows computer up and running. And we'll see that in a moment why I wanted to do that. I want to show how hping3 is a tool that could be used for a distributed denial of service attack. So I'm just going to get rid of the command prompt, and we're going to go to Resource Monitor. So I'm going to call it ResMon. Resource Monitor is a tool that allows us to take a look at the resources on a Windows device. For example, in this case here, I'm looking at the typical devices that we want to get stats on. For example, we have some compute, the CPU, we have memory, we have disk usage, we have network, and we can see the performance of this here. And we're going to use this gauge, these graphs, to show what happens as we go through some hping requests. Okay, so we have it launched. Let's do some housekeeping. First and foremost, remember this is an important tool. Remember to exercise caution when hpinging host or IP addresses, as it may be considered intrusive or against the terms of service of some systems. So we want to make sure we're careful of that. So I'm going to scroll up a little bit, come back on the Kali side, and we're just going ahead and just do a little hping. So I'm going to do an hping3. So most of the times you need sudo to do that. So I'm going to sudo hping3, and I'm going to ping this Windows box. So this Windows box is coming in at 172.16.1.120. We have to put in the password for Kali, and I'm getting healthy ping replies. So in this case here, hping is very similar to regular ping. I can ping and get a reply. So I can send an ICMP request and I get an echo reply. So that looks pretty good. So I'm going to Control C. That's the difference here. You could use Control Z on regular ping. Control C is what we're doing on hping. So I'm going to go ahead and take this off as the regular hping, very similar to regular ping. Okay, so another thing we can do is apply a count to it. Now this is weird, by the way. I'm not sure why we're having high CPU utilization. We're not doing anything particular with this box. Let's see if it'll settle down a little bit, and if not, we can reboot until this flatlines. But this usually shouldn't be an issue with a Windows device, where upon boot up, the CPU should not be pegged at 100% since we haven't started attacking it. But we'll see if it settles down in a moment. If not, we'll go ahead and do a reboot. Okay, so back to hping. So hping is very similar to ping. We can send packets. I can also do a minus count. So I can do -C, and I only want to send 4 packets. And you'll see that it'll go ahead with the -C flag. It allows us to send only a specified number of packets. So we have 4 packets transmitted, 4 packets received, 0% packet loss, and here are our metrics in terms of round trip time, the minimum time, the average, and the max. And you can get that from this data here. So let's scroll down, take off our housekeeping, and while we're at it, let's go ahead and observe the output and see what exactly is happening here. So the length is in 46 bytes, so you can multiply that by 8 for the bits, but this is the size of the packet. This is the IP, is the target device, which is this computer here, the Windows box. And we also have a time to live, which in this case here, it's set to 128. This is the number of hops or routers that the packet can take before it is discarded. In other words, we don't want this thing just pinging around the internet. At some point, it does have to stop and cease. So that's what the time to live number here is. The DF is the don't fragment. We want the packets to stay the same size. Usually the maximum transfer unit for a packet is 1500 bytes. So we want to make sure that it doesn't get bigger than that. This is the ID number, which is important if we're looking at specific packets, especially if we're looking at this in a protocol analyzer like Wireshark. So we can get a specific ID. The source port is where it's coming from. In this case here, we didn't specify a port. We could have with the port command. We could have said, well, okay, port 80, so that way when we target a machine, it knows where it was coming from, what port, and it'll reply to that port. That'll be important in a denial of service attack, especially for attacking web services like port 80 or port 443. In terms of the flags, we will revisit this. This is what we're looking at here. We can set TCP flags. And this is where hping differs from regular ping, where we can actually craft the packet for our purpose. We can test firewall settings, we can actually test bandwidth, we can trace route, and we can also do denial of services attacks like with a Smurf attack, which we will do a little bit later in the exercise here. Then we have the sequence. This was the first one, 0, followed by 1, 2, 3, so on and so forth. We only sent 4 packets. And then the Windows side is a flow control issue, which is we can set a window size when it's a big window. Let's say we set this to 48. We're saying I can send 48 bytes before the receiver has to send an acknowledgement. So if I have a big window, I can send a lot of data. And after a certain period of time when the window is full, then the sender is going to come back and say, yep, I verified that I received everything. A 0 window means that I'm verifying on each packet, which is what we want with ping. And here's the round trip time. So we see all of this here, and this gives us our verifying and looking at the output in case you have to mention this, or just for basic understanding. So let's go ahead and drop down, and we see in this particular case here we had no flag set, so that suggests that we can actually set flags. So I'm going to do both here. I'm going to try and get a twofer. I'm going to bring my command up over here, and I had a minus count. I'm also going to do tac ICMP. I'm going to do an internet control message protocol. I'm also going to specify a source port of 80, and let's just take a look at what this command will look like, especially as it relates to the previous one. So if you see here, slightly different. In this case here, we had no flag set. In this case here, we actually have a flag set because we threw the ICMP flag at it. We also, the port didn't matter too much on this one here because looks like we're not running any web services, but port 80 is what I was looking for, and it didn't call out the source port in this particular one, which is fine. We'll see this again. So these are the flags that I can set, and you see I can set ICMP flags, but there's also other flags that we can set here, and we need to just go over TCP flags just for a moment. And there were a number of them, as you can see below here. So we have a number of flags that we can use, and this points to 2 important ones, really 3, but it's the SYN, SYNAC, and ACK, which is the TCP three-way handshake. So let's go ahead and take a look at this slightly differently. So we'll go to our map, and this is how computers try to communicate. For example, our Kali Linux device, when it wants to open up a TCP connection with the Windows device, the first thing that it does is it sends a SYN packet, a synchronization packet. And the Windows 10 device will reply with a SYN-ACK. So the SYN is like ringing the doorbell or an hello packet saying, hello, I would like to communicate. Then the Windows 10 machine says, hey, I acknowledge your request to communicate. I'm also going to send you a synchronization packet, and I would like to communicate too. And then the third part is the Kali Linux or the client goes back and says, I acknowledge it. And then we have our three-way handshake. So the first packet is a SYN packet. The second one is coming from the server or the destination machine called the SYN-ACK. And then we have the acknowledgement from the original client. This is how all TCP connections are set up, and it's called the TCP three-way handshake. The problem with this is that we can manipulate this for destructive purposes. We can take advantage of the three-way handshake. So I'll show you what I mean with the SYN packet momentarily. So one of the things that we can do is send a SYN packet, and essentially with no intention of sending the acknowledgement. What that does to the target machine is that the target machine is waiting for that acknowledgement and is burning cycles. So let's just see what that looks like on the first part. And I'm going to go back onto the Kali Linux side. We're going to clear, and we're going to actually put in a regular SYN packet. But first, let's do some housekeeping. Okay, with housekeeping done, we're going to send a SYN packet to the Windows 10 device here. Now keep in mind, this is called a half open because we're not closing the three-way handshake. We're basically ringing the doorbell, essentially running away with no intention of closing that that packet, that request to communicate. So let's go ahead and sudo ping. I'm going to change the structure of this a little bit. And the reason why mine looks a little different here is because Control K to kill the rest of this line because we don't need it. And I'm just going to throw the flags towards the end of the command because we can change it easily. So the order doesn't matter as much. I just do sudo hping, I put my target, and this is my flag. So right now what I'm doing here is sending a half open, and I'm accomplishing basically two birds with one stone. I'm killing two birds with one stone. One, I know that this Windows 10 device is actually accepting SYN packets, which is usually something you don't want to do because of what we just mentioned. In the diagram here, I have no intention of closing out this request. I'm saying, hello, I'd like to make a request, and I'm not sending the SYN packet back. So this is called a half open because it's a half request, and this is not good. You can do a denial of service attack with that. So I'm going to close this out, but this is how you send a SYN packet. So we're going to tick this off. And I wanted to show you the reason why we were able to do this with the Windows 10 device is because I have turned off the firewall. If I try and ping the router's sitting over at .1. I don't expect the router to reply. So the router's sitting over here on the .1 interface, sitting over here, and it is configured to not reply to half opens. And that's a good thing. The Windows 10 device, I purposely relaxed it so that way we can actually see what a SYN packet looks like. And that's what you would do in offensive security. You would go around. Part of the cyber kill chain is in part of your reconnaissance, you're going to see if there are devices on your network, because ultimately what you're trying to do is probably a denial of service, which we will see shortly. So we have hping3, we did a half open attack, we see what that looks like. Now the other thing I can do with the SYN is, this was just one packet, if you will. I can actually overwhelm this interface. But in order to do that, let me reboot this Windows 10 because it's hung at 100% from the test previously. So we're going to reboot and have this CPU come back, and it should be more flatlined. So let's reboot and we'll come back in a moment. And we're back, and much better. So now we see what the CPU looks like under normal utilization. It's hovering at single digit at about 4 to 3%. That's fine. Disk input output, disk IO is basically 0. The network is 0. And in terms of memory and errors like hard faults per second, looking pretty good. So this is a healthy looking type of baseline that we were looking for. I was looking more towards the bottom piece. The reason why we had high utilization before the reboot, it turns out this is a new VM, and in the background, for good reason, I had Windows Update. So it was going out there getting the Windows Update. It's trying to have the processor be as efficient as possible and let all the compute resources be dedicated to downloading that update. But now we're looking pretty good. We're back on this side, and what we were discussing is the SYN, the half open. So a SYN packet is a half open. We typically don't like that because if there's no intention to close it with an ACK, then we could be opening up resources that we have to shut down. The other way to do this attack is with the SYN flood using hping. So we can actually flood this interface with a whole bunch of SYN packets, and we're just going to try and overwhelm it. So I take this command here and let's put it onto the Kali Linux side. Okay, so I have my command. It's sudo hping 172.16.1.120 is this Windows box here. We're going to pass the tac flood, and let's see what that looks like. So we have to put in the password for Kali, and it says it's not going to give us any type of replies, and we start to see the CPU utilization go up a bit. And it's trying to deal with the bombardment of packets. And for whatever it's worth, I think this CPU is doing a pretty good job. We're looking at the CPU utilization here. We're looking at disk IO, no effect. Network doesn't appear to be affected, but we have accomplished a couple of things. One, we know that this target is susceptible to SYN floods, so we're going to ratchet up a little bit. But once again, I have to mention that Sending a SYN packet to a server using hping can be done for several purposes. Sometimes it's legitimate and we are looking to see how our routers are configured, but if you point it to an IP address that you don't have permission or authority to do so, it could be potentially malicious. So it's important to understand the context and the intent behind the action. This next one here is going to be a bombardment, and we'll see that in a moment. So first and foremost, let's release our grip on the target machine, and you see that CPU goes right back down, right? We're being quite friendly with it now. It's back to normal compute levels, almost zero and flatline. And now we're going to attack the victim's IP with a very destructive denial of service attack. So let's go ahead and get this command into the Kali Linux side. Okay, so we have our command constructed, and let's break this down a little bit. And this is sort of compiling what we were doing beforehand. So sudo is a super user do command with hping3. You usually have to do that in the super user mode. And we'll break this down. We threw the -C for count. We're throwing 10,000 packets at this particular target. We're also going with the packet size. So the D is the data size. We're going with 120 bytes. The default was 46. We're sending SYN packets, which are open, half opens. We saw that beforehand. So we're ringing the doorbell with no intention of responding. So it's like when children sometimes play a prank. They ring a doorbell and they run away, and when you open the door, there's no one there. Well, we'll be doing this 10,000 times repeatedly. The -W is the window size. So we're saying, you know what? You don't have to check in on acknowledgement until a maximum size of 64. We're targeting port 80, which is the web service on this box. So let's just say there was any web services. We're going to target port 80. It's a flood, which means that we're going to do this incessantly. We're going to bombard it. And then the random source. Rand source is basically we're spoofing or basically impersonating a bunch of source IP addresses. More specifically, it will not look like it's coming from the Kali Linux box. It looks like it's coming from a number of other IP addresses. So if I have an intrusion protection system or an intrusion detection system, I may not be able to find out exactly where this ping flood is coming from. And the 172.16.1.120 is the target machine of this Windows box. So we have everything in play. Before I go ahead, again, I have to make sure that this is clear. There's a need to emphasize that using tools like this for hping3 for net testing or any other purpose without proper authorization is illegal and unethical. Spoofing the source IP address in a network packet can be considered a form of malicious activity and can lead to severe consequences. So once again, this is for educational and testing purposes only in our secure network where we created the PrivNet. Okay, so let's go ahead. We're going to keep an eye on the CPU and let's go ahead. And it tells us that it is in flood mode. No replies will be shown because we're spoofing the source IP address and it's going to be random. So now we start to see that the CPU is going in, and let's see if we can actually do anything. So I'm going to go down into Edge. So Edge is, as many of you know who are using Windows, it's a Windows browser. And let's see if we can actually surf the web here. And it's having difficulty starting, right? So here's where we see we have a problem. We have 100% CPU utilization. We see it's pegged. It went from 0. It says it's having some problems here with the web service. It's trying to recover, but because we're literally bombarding this unit with this target IP, this is what we mean by a denial of service attack. And by distributed, we mean that it's a random source IP address and I can't get any work done, and now it's unresponsive. And once again, we're pegged. I'm going to try and release my grip and see if this will recover and see if we can get some responsiveness out of it. So we're going to Control C, and what we should see is this starts to recover. We see that the CPU utilization should mellow out a little bit. It takes some time for the recovery services to happen. Sometimes it's irreparable, where you have to reboot the machine because it's hung to a point where it can't recover on its own. It's not self-healing. So we'll let this try and recover. While we're at it, I just wanted to quickly show again where are we in the cyber kill chain as it relates to packet crafting or designing packets like half opens with SYNs or with floods, or in this case here we're also doing a spoofing or impersonating the source IP address. We're here in the kill chain where we're in the denial of service attack, which is we're denying this target machine from running its own service. So this is usually an exploitation where for one reason or another, it could be a diversionary tactic. So now the IT team has to deal with this server. And while they're dealing with that server, we could be attacking in a different part of the network. So there's a variety of reasons why red teams would want to do a denial of service attack. So now we see the CPU is trying to recover. It's down to about 10%. Let's go back to Edge. And now we have regular services. So we're back and we're able to go ahead and surf the web. And that's okay. That's what we wanted to do from a Windows 10 perspective. What we wanted to do from an offensive security perspective is we wanted to implement a denial of service attack. We did that with this command, and we know the caveats of doing that. You can't do that unless you have permission or it's your own machines. So we'll do some housekeeping. And we talked about the cyber kill chain. And more importantly, this course is not about telling you how dangerous the internet is. It's more about letting you know about some of these pitfalls and how you can safeguard against them. And let's take a look at some of the mitigation techniques against a SYN flood attack. And let's go back to our diagram. So on our diagram with the three-way handshake, one of the things we can do is we can put a proxy service or a proxy server between clients and servers. In our case, in my case, we use a company called Cloudflare. I'm just using it for illustration purposes. And Cloudflare sits between clients and servers. And we make sure that a complete three-way handshake is completed before we pass it on to the server. So what will happen is a client will send a SYN packet. Cloudflare will reply on behalf of this server and send a SYNAC, synchronization and acknowledgement. And then the client, if it's serious, will send an acknowledgement. And once the three-way handshake is complete, then Cloudflare will go ahead and make that connection with that server. And that's one of the ways that you can mitigate against a half open or one of those SYN flood attacks. There were other ways. The point of bringing this into the Security Plus preparation exam is that we wanted you to know how to do one of these, how to perform them from an hping perspective, also how to mitigate against a SYN flood attack, and also a possible question that may come up looks something like this, which is the question is which of the following hping3 commands is used to perform a SYN flood attack on a target host? Select the best answer and explain why it is appropriate command from a SYN flood attack. So we already know because we did a couple of these where I can do hping3. Technically speaking, this is what we mean by best. It assumes that you already have super user do privileges. I'm just going to get rid of this Bing so you can see the CPU. It assumes you have the sudo privileges enabled. That's what we mean by best answer among the four here. The -S is the SYN flag, and the target host is the IP address that you're targeting. This is the best answer. I always suggest that you do a number of things when you're taking your exams, which is read all of the options to make sure that you are picking the best answer. So I would know this is a fin, this is a push, this looks like a reset. If I'm not sure what these look like, let's go and get some help. Obviously you can't do this on the exam. I'm going to clear. And one of the things that we can do is I can do hping3 tac help. And tac help is going to give me some of the commands that we used. Let's make this a little bit bigger. I can see some of the commands that we have used, and we see we have them here. And more importantly, we can also just go full blown and use the man hping3 to look at the manual, and that'll give you a more robust look at the utility. So hping3, and there you have it. You see the manual will give you all of the different commands. You have fast, faster. This was the flood command that we used. It was send packets as fast as possible. We can be in detailed mode in terms of verbose, and we have a range of options. So that's it with hping3. We now have a list of steps to practice the hping3 command. Once again, keep in mind this is considered a malicious tool if you are using it at computers that you do not have the authority or the permission to test on. So please use it wisely and also study hard for the exam. We'll see you at the next lesson.